Hi everyone, so in this video we are going to solve this assignment. So we have to, this is the first question, we have to find V naught by V in and then you need to tell the value of I naught. So it's a very simple question, you can try it on your own and then you can check the solution. What will happen? This is in a negative feedback, so this 0 will come here. So how much current will be flowing here? V in by R, right? So let's make this circuit on the next page and then we will solve it. So our target is to find V naught by V in and I naught, okay? So this is the circuit. If this is 0, this node will also be 0 because there is a negative feedback involved. Now there is a current would be V in by R. Now the same current will be flowing through this resistance as well. So if the same current is flowing, how much voltage drop will be there? V in voltage drop will be there. So 0 minus V in, this potential will be minus V in. So what will be the current in the upward direction? 0 minus V in by R. 0 minus of V in by R. So in the upward direction, V in by R current is there. So in this resistor, how much current is flowing? V in by R current coming from here and V in by R current coming from downward. So when you solve any problem which involves op-amp, always try to solve it with the concept of currents. If you solve it with the concept of current, even if you are solving a simple network, I always prefer solving the network with the concept of current. If we solve by the current, it becomes easier as per me. If you want to solve by nodal as well, you can certainly solve it by nodal. You will assume a potential V1 here, you will assume a potential V2 here, then you will find V1 in terms of V in and you will find V2 in terms of V in, and then you can certainly write the V naught value. This is also you can do, but I generally prefer solving by the concept of current. So V in by R current coming from downward, V in by R current coming from here. So this current would be 2 V in by R. Now if this current is 2 V in by R, so what will be the voltage drop here? 2 V in will be the voltage drop. Now here the potential is minus V in, here it is minus 2 V in. So this potential will be minus 3 V in. So what will be the current in the upward direction? The current in the upward direction will be 3 V in by R. So in the upward direction 3 V in by R and 2 V in by R current here. So how much current is going here? 5 V in by R. So this current is 5 V in by R. So what will be the voltage drop here? 5 V in by R, not 5 I by R. 5 V in by R. 5 V in by R. So what will be the voltage drop? Current into resistance, 5 V in by R into R. It would be 5 V in. So what will be your V naught? Minus 3 V in, minus 5 V in. What will be the drop here? Minus 8 V in. So minus 8 V in, minus 8 V in is equals to V naught. So what is your V naught by V in? Your V naught by V in is minus 8. That's it. This is the first question. What else you need to find? You need to find the value of I naught. So what do you think? I naught is 0? No, I naught is not 0. Look, input current in the op-amp is 0. Input current is 0. But output current is not 0. Output current can be anything. From here, op-amp can drive any current. So this current that is coming 5 V in by R. Now this current will be coming downward. And since there is no potential here, so this complete current will be flowing like this in this loop. 5 V in by R current will be flowing in this loop. So I naught is negative of 5 V in by R, right? So V in by R current will be flowing in this loop, I naught. So I naught is minus 5 V in by R, that's it. Well and good. So it's not that output current of op-amp is 0. Output current of op-amp is not 0. Input current of op-amp is 0. Well and good. Okay, let's see the next question. So this is the question, you need to find the potential of V naught. So here you can directly see it is a adder, but here potential are there on both of the terminal, inverting and non-inverting. On both of the terminal potential are there. So I told you there is one simple method how to solve these kind of problems. You need to apply the concept of superposition. So we will apply the concept of superposition. First we will consider only inverting terminals, then we will consider non-inverting terminals. So let's just consider only inverting terminal now. So if I am considering only the inverting terminals, what I will do? I will keep all of them to be shorted. So I am only considering these terminals, V6, V5 and V4. So I am shorting them. If I short them, what will happen? Tell me. From this node to ground you see R, from this node to ground you see R, from this node to ground you see R, from this node to ground you see R. So all R will come in parallel. So from this node to ground, what do you see? R by 4. So this complete everything I can replace with R by 4 here. And if this is R by 4, how much current is flowing through this R by 4? 0 ampere current is flowing. And if 0 ampere current is flowing, that means this node will be grounded. If this node is grounded, that means certainly this node will be grounded. This node is 0, this node will also be 0. So you can apply simple nodal analysis now. 0 minus V6 by R. plus 0 minus V5 by R. So I should write directly minus V6 by R plus 0 minus V5 by R. So minus V5 by R, 0 minus V4 by R, V4 by R plus 0 minus V naught by R is equals to 0. So this is not V naught, this I can call V naught A, I will call V naught A. This is V naught A because we are applying superposition theorem, so I have to write V naught B as well. So V naught A is minus of V4 plus V5 plus V6. This is your V naught A. Now we need to find V naught B. So for V naught B, what we need to do? We will only consider V1, V2 and V3. So what I am going to do, I am going to keep all this shorted. This is shorted, this is also shorted, and this is also shorted. So from this node to ground you have R, from this node to ground you have R, for this node to ground you have R. So all these nodes are same only. So from this node to ground you have R by 3. So this complete circuit can be replaced with R by 3. Well and good. Okay. Now your target is just to find this node potential. That's it. If you find this node potential, then what will be your V naught? This I am calling as V naught B. This I am calling as V naught B. So exactly what is your V naught B? Your V naught B is 1 plus RF by R, because input is at non-inverting terminal. So 1 plus RF by R into V. So your V naught is 4V. This is your V naught. V naught is 4 into V. 4 into V. So you need to find the potential V. So how will you find the potential V? You can simply apply the nodal V minus V1 by R plus V minus V2 by R plus V minus V3 by R and plus V by R plus V by R is equals to 0. So 4V by R is equals to V1. Let's forget about this R. So it would be 4V1, 4V. 4V would be equals to V1 plus V2 plus V3. 4V would be equals to V1 plus V2 plus V3. Let's just call this as equation 1, this as equation 2 and this as equation 3. So by equation 2 and 3 and 3, what you are getting as V naught B? So your V naught B is 4V is equals to V1 plus V2 plus V3. V1 plus V2 plus V3. This is your V naught B. So what is your total V naught? What is your total V naught? V naught is V naught A plus V naught B. So your V naught B was V1 plus V2 plus V3 and your V naught A was minus of all of them. It was minus V4 minus V5 minus V6. Minus V4 minus V5 minus V6. So this is what you get at the output. So very simple kind of question, very easy. Well and good. Let's move towards the next question now. So in this question you need to find the I naught current. The I naught current is this current that is going into this 2 kilo. You need to find the maximum amplitude of I naught. So simply you need to find I naught current, then you can write down the maximum amplitude as well. So how will you do it? What will be the potential coming here? That would be 2V in by 3. Say yes or no. Simple potential divider. 20 kilo ohm divided by 20 plus 10. 2 by 3 into V in. So this potential is 2V in by 3. The same potential will be applied here, but I am not going to do this because I know if I know the potential as at non-inverting terminal, if I know the potential at non-inverting terminal, what will be my output? My output will be 1 plus RF by R. 1 plus RF by R into 2V in by 3. The potential here into 1 plus RF by R. RF is 98K and this is 7K. So 98 by 7K. What you will get? 14. So it would be 15 into 2V in by 3. So it would be 10V in. So what you are getting here is 10 V in. So what will be your I naught? I naught is simply V naught by 2k, right? So tan V in by 2k. So what is V in? V in is 0.5 sin omega t. So it would be 5 sin omega t divided by 2k. So your I out would be 2.5 sin omega t milliampere. This is your I naught. This is your I naught. So what is your I naught max? Your I naught max is 2.5 milliampere. That's it. I naught is 2.5 milliampere. Very easy question. 2 V in by 3 was coming. 1 plus RF by R. 15 into 2 V in by 3. Then 10 V in 5 sin omega t divided by 2k. That's it. 10 V in by 2k. 5 by 2k. 2.5 sin omega t milliampere. Right? They could have asked the current here as well. Can you find the current here as well? Yeah, you can find. If you know the current I naught, if you know the current in this direction, then you can find the current here as well. You can find any current, right? How will you find this current? What will be this node? This node will be 2 V in by 3. What is this node? This node is tan V in. So now you can find the current in this direction. So if you know this current and if you know this current, so let's call this current as X and this current as Y. So what is X plus Y is equals to I naught. So from there you can find the value of Y because you have the value of X current. So these kind of question can be asked in the op-amp questions. So these you can certainly solve. We will practice a lot. So these kind of questions will be coming in front of you. So you will be able to answer all those questions. Well and good. Let's move towards the next question. This is the question. You have to find the sign of A and B such that your op-amp is working in negative feedback. So this is the first question. What do you think? What will be the sign of A and B? A would be positive or A would be negative, or B would be positive or B would be negative. What do you think? What did I tell you? Pick the output of op-amp. This is the output of op-amp. If this is increasing, what will happen to this node? This node will also increase because this is common source. You are going from gate to source. This we have already studied in MOSFET. If I am going to gate to source, then there is 0 degree phase shift. So if this is increasing, this will also increase. If I am going from gate to drain, then there is 180 degree phase shift. If I was going from here to here, then it would have been 180 degree phase shift. But from here to here, there is 0 degree phase shift. Now, if this node is increasing, that means certainly this node is also increasing because the same node is coming here. Now, what you will put? What do you want? For negative feedback, if your output is increasing, then you want your output to decrease. Eventually, you want your output to decrease, right? That's why we call it negative feedback. So, if this node is increasing and you want your output to decrease, so what you will put at A? Negative, right? And what you will put at B? Positive. Did you understand this? Or there is one very simple method. From here to here, how much phase shift is there? 0 degree. But you need total 180 degree phase shift. In negative feedback, we need 180 degree phase shift. This we have already studied in feedback amplifier. So I highly recommend you to study feedback amplifier before studying op-amp. Look, a lot of teacher will teach you op-amp without teaching feedback amplifier. And you will be thinking that you are understanding op-amp. But the actual understanding will come if you go lecture wise lecture. It's not that you should be coming in between. If you go lecture by lecture, from zero you are coming, then till now you must be very, very comfortable. And I highly recommend to study network analysis from me as well. If you study network analysis as well, you will get to learn a lot of new things. Later on, we are going to study A-stable multivibrator and integrator and differentiator. So their concept of network analysis will be used. Their transient analysis will be used. So you should be comfortable with all those analysis, right? So from here to here, there is 180 degree phase shift, and in negative feedback, you need 180 degree phase shift. So from here to here, there is 0 degree phase shift. Now, from here to here, there is 0 degree phase shift, and from here to here, there is also 0 degree phase shift because this node is directly coming here. So what do you need? You need 180 degree phase shift. So you have to keep A as negative and B as positive because from here to here, then you will get 180 degree phase shift. If your A is negative, if your A is positive, then from here to here, you will get 0 degree phase shift. Why is it so? Because what is your V naught? V naught is some gain I am calling it K into V positive minus V negative. So if V negative is increasing, then your output would decrease. If V negative is increasing, then your output would decrease. That's what we call 180 degree phase shift. But if your V positive is increasing, your output will increase. There is 0 degree phase shift. or 360 degree you can say, or 720 you can say. And in this case what you can say, 180 degree or 180 plus 360 again, 180 plus 360, what it will be, 540. Add 360 again, what you will get, 540 plus 360, 0 0 900 degree. So these kind of phase shift you need, right? So I'm not going to write it here, and this also we don't need to write. So directly by increasing node and increasing node, you can get to know that if this node is increasing, this node is certainly increasing, and if this node is increasing, this node is also increasing. Now you want your output node to decrease, so your A should be negative and B should be positive. If A is negative, then certainly this node will decrease. Okay, so your A should be negative and B should be positive. Well and good. So this is the first question. So now this op-amp is working in negative feedback. So find the small signal current IL in terms of small signal voltage Vin. Okay. So if there is negative feedback, then certainly, if there is negative feedback, then certainly virtual short is valid. So this Vin would come here. If this Vin is coming here, then certainly this Vin is coming here. So I should draw it on the next page only. We should not. Let's just copy it. Because what I am going to do is, I am going to, because they asked the small signal current, so this DC bias will be shorted. This DC bias is shorted. So if this is Vin, so what will be the current here? Vin by RD. Now this Vin by RD current is equals to IL. Vin by RD current is equals to minus of IL. So what is your IL? IL is minus Vin by RD. That's it. Okay. Understood this question? Very easy. Now I will just I will do a very small change in this particular question, and I will make a new question out of it. So I will add a page. What will be your answer now? I need the answer of this question. What should be the sign of A and B such that your op-amp is working in negative feedback? Try to increase this node. If this node increases, then what will happen to this node? Tell me. You are going from gate to drain. Gate to drain. There is 180 degree inversion. There is already 180 degree inversion. So if this node is increasing, that means this node is decreasing. If this node is decreasing, then certainly this node is decreasing. You don't want any inversion now. From here to here, you need 0 degree inversion. So if you need 0 degree inversion, what do you need? A to be positive and B to be negative. Now it feels like that feedback is coming into the positive side, but it is a negative feedback. That's why I told you, don't get confused with the sign. These kind of questions we have already seen in the feedback topology chapter, right? You never should treat the feedback just by the sign. You should see the phase shift. If output is decreasing, output is increasing, this node is decreasing. Now this node is decreasing. Now you want your output to decrease only. So if this A is positive, if A is positive, so what is your output? Output is K into V positive minus V negative. So if this node is increasing, if this node is decreasing, then output will certainly decrease. So if this node is decreasing, output will decrease only. So never ever treat that just by seeing the sign. You should not say that it is a positive feedback or negative feedback. You should be attentive that from here to here I am already having 180 degree phase shift. So in the loop I don't want any other phase shift. If there is one more 80 degree phase shift, that means it will become positive feedback. Already 180 degree phase shift is there. If I introduce one more 80 degree phase shift, then total phase shift will be 360 degree, and 360 degree is equivalent to 0 degree, and 0 degree phase shift means there is positive feedback. But I don't want that. I want 180 degree phase shift only. So here from the op-amp I will give 0 degree phase shift, and for op-amp to give 0 degree phase shift, A has to be positive and B has to be negative. So that's why it will feel like that it is a positive feedback, but in actual it is a negative feedback, right? Because the MOS is giving you 180 degree phase shift. So if this increases, then certainly this will decrease, because if this is decreasing, then certainly this will decrease if A is positive. So what is your final answer? What is the answer of A? That is, your A should be positive and B should be negative, right? And you need to find the small signal current IL. Okay, then it would be the same only, no? Small signal current, this V in will be copied here, and the current will be flowing in the upward only. So V in by RD is equals to minus IL. Now no one will say, sir, how in and most the current will flow in upward direction? Will you say that? Will you say this? No, because you have studied most. This is a small signal current. This is not the large signal current. This is a small signal current. So small signal current can certainly flow in from down to up as well, right? So this would be V in by RD, minus of V in by RD. So IL would be minus of V in by RD. Well and good. Okay. So let's solve the next question now. Just a small modification is there in this question. Yesterday I showed you the questions now for the assignment. So I forgot to show this resistance R1. So today only I added it. So I'm really sorry for this mistake. You must have wasted your time here. I'm really sorry for that. But yeah, let's try to solve this question now. You can pause the video. You can solve this problem now. So first thing you need to find, this is the MSQ question. So multiple options are correct. In these four options, there can be multiple options which are correct, or there can be one option as well which are correct. It's not necessary that there will be multiple option. There can be one option as well. Okay, so yeah. So what is the question? First, you need to tell the sign of A and B so that both of the op-amp are working in negative feedback. You need to tell the sign of A and B so that both of the op-amp are working in negative feedback. So this is certainly working in negative feedback. Why so? Because if this node increases, then certainly this node will increase, because this is directly connecting to a impedance only. What will be the potential here? Let's just call this node is V. So what will be the potential at V? 2R2 upon 2R2 plus Z into V node. So if V node increases, then certainly V will increase. So if V node is increasing, V is increasing. And if V node is increasing, that means what is your V node? V node is some constant K, V negative minus V positive. Sorry, V positive minus V negative. So if V negative is increasing, then certainly V node will decrease, right? So there is a negative feedback, that's for sure. So this is decreasing, there is no doubt about it, right? Let's come to this op-amp. So what is the output of op-amp? This is the output of op-amp. Now what do you see? There is this feedback present as well, and there is this feedback present as well. So there are two feedback present. But do you remember one thing? I told you, when you need to check the sign of feedback, you always need to short circuit your input. Say yes or no. When you are checking the sign of feedback, you always need to short circuit your input. So let's copy this circuit, and when I am checking the sign of feedback, I am going to short circuit my input. So there you go. I am short circuiting my input now. So this input is shorted. So if input is shorted, what is coming at this node? At node A. What is coming at node A? Node A is at 0 only. Node A is at 0. Now if this node increases, then certainly this node will increase. But if this node increases, is there any effect on this node? On the node A is at 0 only. But node, let's just call node B. Node B is increasing when, if, let's just call this node as V dash. If V dash increases. So if V dash increases, then certainly node B is increasing, but there is no effect on node A, right? Node A is at 0 potential. Why? Because I told you, when you are checking the sign of feedback, you need to nullify the effect of input. If voltage source is there, I will make it short circuit. If current source was there, I would have made it open circuit. So this I made short circuit. So if this node increases, then certainly this node is increasing. If this node is increasing and I want my final output to decrease, so what I will keep? I will keep this B as negative and A as positive. Say yes or no. I want my final output to increase. So basically from here to here, or I can say from here to here, there is 0 degree phase shift. So from here to here, I need 180 degree phase shift. I need 180 degree phase shift. So if I need 180 degree phase shift, that means I need to pick B as negative and A as positive. Say yes or no. So B will be negative and A will be positive. The main point was you should never forget that you should keep your input voltage to shorted. You should nullify the effect of input when you are checking the sign of feedback, right? So B is negative and A is positive. So this we have understood. Now we need to solve the problem. What was asked? Arey yaar. So first task we have done. B is negative and A is positive. A is positive and B is negative. You need to find the R in potential. If this node is V in, this node will also be V in. If this node is V in, what will be the potential of this node? Tell me directly. 1 plus RF by R, 1 plus RF, R3 by R3 into V in. So this node will be 2V in. Or you can apply nodal as well. If you are not understanding, you can apply nodal as well. What you will do? You will tell this node as V dash. So you can apply nodal here. V in minus V dash, V in minus V dash by R3 plus V in by R3 is equals to 0. So your V dash is 2V in. This also you can do. So this node is 2V in now. This node is 2V in. Now if this node is 2V in, what will be the potential at this node? This node will be, what will be the potential at this node? Output will be what? This is simply an inverting amplifier. This is an inverting amplifier only, right? Or you can apply nodal at this node. At this node you can apply nodal. So what will be the nodal? 0 minus V node by Z plus 0 minus 2V in by 2R, 2R2, 0 minus 2V in by 2R2 and 0 minus V node by Z is equals to 0. So V naught is equals to 2 and 2 are getting cancelled, minus Z by R2 into V in. This is your V naught. This you can call as equation 1, minus Z by R2 into V in. What is your target? What is the second question? So first question was A should be positive and B should be negative. Now you need to talk about input impedance. Your target is to find input impedance. You need to find input impedance. What is input impedance? V in by I in. So your target is to find V in by I in. That's it. This is your target. V in by I in. So what will be this potential? This potential is V in. So if you apply nodal at V in, so what that will be? V in minus 2V in by R1 plus V in minus this node. V in minus, what is this node? This node is minus Z by R2 into V in. So what it will be? V in minus of Z by R2. Z by R2 into V in divided by R1 is equals to I in. That's it. V in minus 2 V in by R1 plus V in minus of Z by R2 into V in divided by R1 is equals to I in. So minus V in plus Z by R2 into V in is equals to I in into R1. So V in and V in is getting cancelled. So from here what do you see? V in by I in is R1 into R. What is R bhai? What is R? Z by R2 it is. Z by R2. Yeah, Z by R2. This was Z by R2. So V in by I in is R1 into R2 divided by Z. This is simply mathematics calculation. You should be doing it on your own rather than seeing my solution. Rather than watching my solution, you should be doing it on your own. So what is your R in? R in is R1 by R2 into Z. So if your Z is an inductor, what will be your R in? Do I have a page? Yes. So my R in is becoming R1 by R2 by Z. If my Z is inductor, then my Z would be J omega L, right? Z would be J omega L. So R in is R1 R2 divided by J omega L. So this J would go upward. It would be minus J R1 R2 divided by omega L. So isn't it acting as a capacitor? What is the impedance provided by the capacitor? What is the impedance provided by the capacitor? That is 1 by j omega c, or you can write minus j by omega c. So it is providing you a negative impedance in imaginary axis. Negative impedance in imaginary axis, that shows capacitor, and positive impedance in imaginary axis, that shows inductor. I hope you remember the phasor. So if your phasor is like this, it is inductor. If your phasor is like this, it is capacitor. So this is minus j some value, minus j into some value. That means it is acting as a capacitor. So what is the statement written? The statement written is, considering negative feedback, R in acts as inductor if Z is inductor. That is wrong. R in acts as capacitor if Z is inductor. Are you getting this point? If Z is inductor, then R in is capacitor. And if Z is capacitor, that means Z would be 1 by j omega c. So R in would be R1 by R2 divided by 1 by j omega c. So that would be j omega c R1 R2, right? So what is this? This is a inductor, because the inductor will give you a response like j into some value, because what is the impedance provided by the inductor? That is j omega l. So j into some value. If it was minus j into some value, then it would have been capacitor. If it is j into some value, then it means it is a inductor, right? So it is acting as a inductor. So if Z is capacitor, then your Rin is inductor, right? So this particular network, this particular circuit is known as generalized impedance converter. Impedance converter. It is converting your impedance. If you have an inductor and you want your input impedance to act as a capacitor, you have an impedance, in your lab you have an inductor, but your manager says that you need to make a circuit such that your inductor is working as a capacitor. So what is the input impedance of this? You will make a box, you will keep this circuit, and you will go to your manager and say, sir, this particular box is acting as a capacitor. Then he will calculate the input impedance and he will get minus j into some value, and then he will say, okay, it is acting as a capacitor only. So this is a generalized impedance converter. If you have the inductor, you can make capacitor from it. If you have a capacitor, you can make inductor from it. Say yes or no. And if you have a resistor only, then it will be giving a resistor only, because what was the output? R1 R2 by Z. Input impedance was R1 R2 by Z. So only one option is correct here. This is also wrong. This is also wrong. So deliberately I wrote MSQ here so that you get confused. So in the examination, in GATE examination, when I wrote the GATE examination in 2022, there was around 4 to 5 question, not 4 to 5 question. There was around 3 to 4 question where it was written MSQ, but only one option was correct. So in the examination, it may happen that they are saying it as a MSQ, but only one option is correct. So you should be attentive. That's why I took this question and I made 4 options. So you should be thinking which option will be correct, but only one option is correct. So you should be confident enough in the examination to put the correct answer. Okay, so only one option is correct. Considering negative feedback, Rin acts as capacitor if Z is inductor, and Rin acts as inductor if Z is capacitor. So impedance conversion is there. Say yes or no. Are you getting this point? Everything is crystal clear. How did I find the V0 value? How did I find the Rin value? And how did I find the sign of op-amp for negative feedback? So for sign of op-amp for negative feedback, this is how I find that if this increases, then this node will increase. Then certainly I need my output to decrease. But there are two feedback involved. But at the positive node, nothing is happening because Vin is shorted. So if Vin is shorted, there was nothing happening. So only B has to be negative and A will be positive. Well and good. Let's move towards the next question now. This is a question, very easy question. You need to find the potential of V0. If this is V1, what will be this? Tell me. If this is V1, what will be this? It will be V1 into 1 plus R by R dash. R by R dash, not R1. This node would be V1 into 1 plus RF by R. 1 plus R by R dash. Now, basically, you can call this node as V2 and simply apply the nodal analysis, or you can apply the superposition theorem as well. Because for this op amp, you have two kind of inputs, V2 and the other input is this. You can do this, or certainly there is a negative feedback involved, so this V2 will be carried here and you can apply nodal analysis as well. So let's just solve by nodal and then you can solve by the superposition on your own. You can solve by the superposition on your own, but let's solve by nodal. V2 minus V1 into 1 plus R by R dash divided by R plus V2 minus V0 by R dash. I guess it will make our calculation complex only, right? How will I solve it now? Certainly I can solve, but it is being complex. This is making my calculation complex. Better I should solve it with the concept of superposition, right? So I will solve it with the concept of superposition only in the next page. Arey yaar. So this potential I was getting was V1 into 1 plus V1 into 1 plus R by R dash, right? And forget about this node. So considering only V2, I am going to write my output directly now. Considering only V2, this will be shorted, so what will be the output? Minus R dash by R into V2. Say yes or no. This I am shorting. This I am shorting. If this is shorted, then what will be the output? Minus R dash by R into V2. Plus, if this is, wait a minute, sorry. I'm really sorry for this minor mistake. Really sorry. So if this is shorted, what will be the output? Output will be 1 plus R dash by R into V2. Because this is a non-inverting amplifier, no? So 1 plus R dash by R into V2. And if I short circuit V2, and only consider this one, so what will be the output? Output will be minus R dash by R into 1 plus R by R dash, 1 plus R by R dash, yeah, 1 plus R by R dash into V2. That's it. Is there any way to reduce our final answer? I guess we can try it. Or into V2, it would be V1. Look, first I consider only V2 source and I consider this as shorted. If this was shorted, then what would be the answer? It is a non-inverting amplifier. So 1 plus R dash by R into V2. That's it. Then what did I do? I considered this as shorted. Then I only considered V1 into 1 plus R by R dash. This as a voltage source. So what will be the answer? This is an inverting amplifier. So minus R dash by R into V1 into 1 plus R by R dash. That's it. Now I am thinking if I can reduce my final expression. V2 plus R dash by R into V2 minus R dash by R into V1 minus V1. Say yes or no. Because this is R dash by R into V1 and this R dash and R dash will get cancelled. R and R will get cancelled, minus V1. That's it. So V2 minus V1 I am getting here plus R dash by R V2 minus V1 I am getting here. So my final output is becoming 1 plus R dash by R V2 minus V1. So very interesting result. It is acting as a differential amplifier. It is acting as a differential amplifier only, no? So two V2 and V1 are getting subtracted and they are being amplified. Their difference are being amplified and they are getting subtracted. Their difference are being amplified with the factor of 1 plus R dash by R. Well and good. Let's move towards the next and final question. This is the final question of our this assignment 12. right? So you need to draw the transfer characteristics for V0 versus V. Now VR value should be defined here, if VR is positive or VR is negative. So let's just assume, if we first you need to assume VR is positive and then you need to take VR is negative, or I should take a value. Let's take a value. Let's take a value. We can frame two questions out of it. First I am taking VR to be positive. So what will be your transfer characteristics? So what do you mean by this? There are two Zener diode. There are two Zener diode. This is what it means, that there are two Zener diode. That's it. Okay, sometimes they can show it in one only. There are two Zener diode connected like this. So first let's see, if Vin is greater than 5 volt, then what will be your output? Output will be minus 10 volt. Not your output. I am calling this node as V0 dash. So what will be your V0 dash? V0 dash will be minus 10. So now your circuit is R this is minus 10 and this is your V0. So what will happen? This minus 10 will come. So better I should make it as a 2 Zener only. Now what will happen? You can apply open circuit test. If I am applying open circuit test, this minus 10 will come here. If this minus 10 is coming here, there is high chances that this Zener will go into breakdown, because Vz is 6.3. So let's just assume that this Zener is going into breakdown. If that is going into breakdown, then what will happen? This minus 10 was here. If that is going into breakdown, then you will make it as a battery of 6.3. The negative terminal will be positive and positive terminal will be negative. So this will be made a battery of 6.3. Here we were assuming it was minus 10. If it is minus 10, this would be minus 10 plus 6.3. Minus 10 plus 6.3. What is that? Minus 3.7. So at the negative node you are having minus 3.7. That means this will go into what? This will go into forward bias. This Zener will go into forward bias. In the reverse bias, Zener acts as a battery of Vz, but in forward bias it acts as a normal diode. So it is going into forward bias. So the lower Zener is going into forward bias. So it will be replaced with a simple battery of 0.7 volt. Of 0.7 volt. So it was replaced with the battery of 6.3 volt and it was replaced with the battery of 0.7 volt. And here we were having minus 10 volt and this was your V0. So what is the V0 you are getting? V0 you are getting is minus 7 volt. That's it. So if your Vin is greater than 5 volt, if your Vin is greater than 5 volt, so this is what you are getting. This is a simple question on diode circuit only. If Vin was greater than 5 volt, your output was minus Vset, minus 10 volt. If output was minus 10 volt, then this Zener was going into breakdown. This Zener was going into breakdown. So it was replaced with the battery. Then you need to check the operating condition of this one as well. Then you got to know that if upper one is going into breakdown, then certainly my lower diode will be in the forward bias. So that will be replaced with the battery of 0.7. So my output will be 0.7 minus 0.7 minus 6.3. Output will be minus 7 volt. Well and good. So this is my output. Now secondly, if my Vin is less than 5 volt, if my Vin is less than 5 volt, if Vin is less than 5 volt, then what will be my V0 dash? V0 dash will be minus 10 volt. Oh sorry, if Vin is less than 5 volt, my V0 dash will be plus 10 volt. Sorry. My V0 dash will be plus 10 volt. This is your V0 and this is your plus 10 volt. अरे यार बार बार माइनस लिख रहा हूँ. It would be plus 10 volt. This is resistance R. Now again we need to check the operating condition. So again I am going to apply open circuit test. So assuming 10 volt will come here. If 10 volt comes here, there is high chances that it can go into forward bias. So I am assuming that my first Zener is going into forward bias. So assuming that it is going into forward bias. So if it is going into forward bias, it will be replaced with a battery of 0.7. And here you are having 10 volt. So if this is 10, what will be this potential? This potential will become minus, no, sorry. plus 9.3. 10 minus 0.7, it would be 9.3. So where the lower diode will go? This potential is 9.3. So at the end you are having 9.3. So that means it is going into reverse bias, but since it is Zener and you are having greater than 6.7 volt, so it will certainly go into breakdown. So the lower one is going into breakdown. Did you understand it? Here we are applying open circuit test only. So 10 volt was coming. 10 volt was coming. So there is high chances that this will go into forward bias. So I assumed it is going into forward bias. So if it is going into forward bias, so 10 is coming here, then this would be 9.3. If here I am having 9.3, then certainly it is going into breakdown. Because at N side you are having 9.3, at P side you are having 0. 0 and 9.3. There is a reverse bias of minus 9.3. But if you get reverse bias of 6.3 only, it will go into breakdown. So this is going into breakdown. This goes into breakdown and it will be replaced with the battery of 6.3 volt, and this was 10 volt. This was R. So what is your V naught? Your V naught is 7 volt, right? 7 volt. Your V naught is 7 volt. Can you draw the transfer characteristics on your own? So V naught versus V in. So if V in is greater than 5 volt, this was your threshold, 5 volt. If V in was greater than 5 volt, you are getting minus 7, and if it was less than 5 volt, you are getting plus 7. V in is less than 5 volt, you are getting plus 7. V in is greater than 5 volt, you are getting minus 7 volt. So that's it. This is the characteristics. Well and good. Let's not make this sign. Okay. So this is the characteristics. Everything is crystal clear. Now if V in was if this node was negative, you can draw the transfer characteristics on your own. Right? If V in is greater than minus 5, what will happen? If V in is greater than minus 5, your output will be minus 10. If V in is greater than minus 5, your output will be minus 10. So actually, the transfer characteristics will just shift. What will happen is that this transfer characteristic will shift. That's it. Nothing else will happen. Look, I will copy this question. I will just copy this question. We'll paste it here. I will put 5 instead of minus 5. This is your V naught dash. So if your V in is greater than minus 5, your output will be, your V naught dash will be minus 10. V naught dash will be minus 10. So what will be your V naught? If your V naught dash is minus 10, if your V naught dash is minus 10, this will be the circuit. Then what is the V naught you get? Minus 7 volt, right? V naught you get is minus 7 volt. So basically V naught you will get is minus 7 volt. Because it is minus 10, then certainly it will go into breakdown. So this will become 6.3 and this will become 0.7. So minus 0.7 minus 6.3, it will be minus 7 volt. And if your V in is less than minus 5 volt, then what will be your V naught dash? Your V naught dash will be 10 volt. And if your V naught dash is 10 volt, then what will be your V naught? V naught will be plus 7, right? Your V naught will be plus 7. So you can draw the transfer characteristics. Just the previous transfer characteristic is just shifted, nothing else. Your transition point is minus 5 volt. Previously it was plus 7 volt. If your V in is less than minus 5 volt. If your V in is less than minus 5 volt, it is plus 7 volt. And if it is greater than, it is minus 7 volt. That's it. So this assignment we have done. It was a very good assignment. You must have felt confidence. You must have felt confident after solving this particular assignment. Okay, so in the next lecture, we are going to study more on op-amp. There are more configuration. There are non-linear application. There are a lot of things: integrator, differentiator. There are offset in the op-amp. Then there are clamper circuit. There is peak detector circuit. So all those we are going to study, but one by one. So let's meet you in the next lecture. Okay, thank you.